force of 15 Newton stretches a spring to a total length of 30 cm. An additional force of 10 Newton stretches the spring 5 cm further. Find the natural length of the spring. So as easy as ABC, we're going to solve that. So now we have the first force there. I'll label it F1 to be equals to what? 15 Newton. And it stretches the spring to a total length of 30 Newton. That means the length L that it stretches the spring is what? 30 cm. So an additional force, I'll label that additional force F2. That means a force has been added to the initial force. An additional force of 10 Newton, F2, which is 15 plus 10. That's the additional force of 10 stretches the spring. This additional force is now 25 Newton. Stretches the spring 5 cm further. That means the length L2, the new length of this thing, 5 cm further means 30 plus 5. 30 plus 5 equals to 35. 35 cm. So the first force, 15 Newton, stretched it 30 cm. That is, it stretched the original plus the extension. Now the second force, additional force was added to the first one, which is now 25, and now it stretches it 35 cm. So the equation says find the natural length of the spring. So let the natural length be L0. Let it be what we are looking for. So according to Hooke's law states that the force is directly proportional to the extension, provided the properties of the spring remains constant. So this is Hooke's law, equals to Ke. E here represents extension, and then K here represents force constant. So now, what is the extension? For the first instance, 15 Newton, we write here 15 equals to K times extension. Extension is the new length minus original length. So from the question, they said he stretched it to a total of 30 cm. So this is the new length of the spring, which means it's not the original. So that will be 30 minus original length L0. So with this, I form my first equation. And from here, I can make K the subject of the formula. If you make K the subject of the formula by dividing both sides by 30 minus L0, that will be, you'll be having 15 divided by 30 minus L0. Okay? Now we look at the second instance, a force 25 Newton. The second instance, F2, or let me just write 25 there at once. Second instance, 25 equals to K. K will remain the same because the properties of the spring, the material, is constant. Equals to the new length that is the additional force stretched it was 35 cm. So that will be 35 minus the original length. Minus the original length will give you the extension this time around. So if you still make K the subject of the formula there, you have that your K will be equals to what? 25. 25 divided by 35 minus L0. So in that regard, since you have your first equation here, 1, and then you have your second equation here, equation 2, and you see that K, the first equation equals to K, the second equation equals to K, so which means that what is here is equals to what is here. So if you equate equation 1 and 2, because they both have K as their subjects of the formula, if you equate it, you now have 15 divided by 30 minus L naught equals to 25 divided by 35 minus L naught. So what is left now is for us to solve the mathematics. 5 will cancel 15 3 times, 5 will cancel 5 5 times, 5 will cancel 25 5 times, sorry. So you cross multiply 3 times the denominator of that one, that will be 3, open bracket, 35 minus L naught equals to 5 times that, 5 open bracket, 30 minus L naught. Okay, so 35 times 3 is 105. As we open the bracket there, 105 minus 3 L naught. 5 times that, that will be 150. 150 minus 5 L naught. So you collect like terms. If you collect like terms properly, you have 5 L naught minus 3 L naught will give you 150 minus 105. Minus 105. So this will give you 2 L naught equals to what? That minus that will give you 45. So if you divide both sides by 2, your L naught will be equals to 45 divided by 2, which will give you 22.5 cm. So the original length of the string is 22.5 cm. Option D. So with this, you can also calculate the spring constant if you are being asked. How would you calculate the spring constant? Now you know the original length. Let's leave it there. So you subscribe to the channel, and then for online tutorials you can join my WhatsApp group through the link in the description. All right, thank you.